Hello everyone. So I'm indeed in charge of the group-wise IPv6 program, which has been launched by France Telecom several years ago. Actually, it was in May 2008, and this is a structure which is basically meant to define the group's IPv6 strategy and also to accompany the different affiliates of the group in enforcing such strategy. So we started this program, which is seen as the last mile before the actual deployment, and this presentation is actually organized into two parts. The first part is to further elaborate on the strategy itself, and the second part is to give you a status of the current deployment within the group. So just a few words about us before I jump into the interesting discussion. So we are now 170,000 employees worldwide, including a little more than 100,000 people in France. We've got 227 million customers worldwide, including 15 million ADSL customers worldwide. In France, this is something like a little more than 9 million. And in France, we've got something like 27 million mobile customers. And the turnover on September 30, 2012 was 32+ billion euros, which means that we should probably reach something like 45-46 billion euros for the 2012 year. Okay, so I guess some of the familiar faces in this room already know some of the slides of this presentation, because this is something which I had the opportunity to present several times. I just wanted to very much insist on the fact that from a service provider standpoint, we actually have two problems. The number one problem being obviously the global IPv4 address depletion, which, as you know, has become a reality, and the solution to that problem is the introduction of IPv6 in our networking and service infrastructures. But there is another problem, which is which can be seen as some kind of collateral effect of the global IPv4 address depletion, and which is basically our ability to guarantee our new customers that they will still be able to access the IPv4 internet during the forthcoming transition period, even though we won't be able to assign these new customers a global IPv4 address anymore. And we don't have any solution to that problem. I will spend a few words regarding what we will be doing to address that kind of issue, but admittedly, this is not something we will encourage. We will actually rely upon the introduction of basically the network address translation techniques in our network to encourage our users to use IPv6 instead, and we'll see why in a minute. So this is a slide that tells many stories. This is the very basis of our strategy. The keywords here is growth stack, mostly because we think this is the most attractive solution or migration technique, if you will, to smoothly introduce IPv6 in each and every component of our services, and yet being as transparent as possible to our customers, because obviously most of our customers don't really care whether they access the internet through an IPv4 connection or an IPv6 connection, but they want to make sure they will access the services they have subscribed to with the appropriate level of quality. So this picture is mostly focused on the fixed environment. I forgot to mention that the program covers not only the fixed but also the mobile environment, as well as the residential and the corporate customers, and I'll get back to that in a minute also. So in a few words, as far as the introduction of IPv6 is concerned, the network devices, as well as the service platforms, as well as the CPE devices that we deploy in our customers' premises will become growth stack routers, and in some affiliates, this is already the case, meaning that IPv6 traffic and IPv4 traffic will be processed indifferently depending on the nature of the contents the customers want to access. So this is quite a dramatic evolution, especially on the CPE side. Maybe what is special with France Telecom is that we develop our own CPE, and then this is something which is further industrialized by a couple of vendors, so namely Telecom and Sagem, which provide the different software versions that include our functional requirements and which take into account prototype developments. So it's quite different from other operators who have to rely on off-the-shelf CPE, which may be another technological issue to address when comes the time to introduce IPv6 capabilities. So from that standpoint, it's slightly more comfortable, if I may say so. Customers will be assigned a /56 prefix. This is also true for the corporate customers. The corporate customers will have the ability to choose a /48 assignment if they need that kind of size of prefix. Typically, we use prefix delegation, where the BRAS device will embed what we call a delegated router functionality, which will be responsible to assign the prefix once the AAA chain has been solicited and confirmed that the customer is actually entitled to be assigned an IPv6 prefix. As far as the IPv6 terminals are concerned, we will still rely upon the typical stateless addressable configuration mechanism, so that these terminals will be able to form their own IPv6 address that will be assigned to the interface which connects these terminals to the LAN that connects the CPE. Regarding the forwarding of the IPv6 traffic, I guess most, if not all, our networking infrastructures in each and every affiliate is based upon MPLS switching technique, which means that we decided to run a 6P design where we do not have to activate a specific IPv6 routing protocol for the computation of IPv6 routes. We will simply rely upon the MPLS machinery, meaning that the MPLS LSPs will not only convey the IPv4 traffic, but also the IPv6 traffic, which has an interesting property as far as the OpEx budget are concerned regarding the maintenance and the evolution of the networking devices. Last but not least, the IT infrastructure will become fully dual stack. This is admittedly one of our major technical challenges, especially in large affiliates such as France or Poland, where, as usual, the operators develop their own in-house information system, which means that we've got very, very old applications, especially in the area of order processing, which need to be completely redesigned to include a simple IPv6 address format, so that the customer can be uniquely identified with this new IPv6 addressing scheme. So this is where the technical challenges reside, mostly because of cultural background, if I may say so, which means that we need to train more and more colleagues, obviously, so that they can get the appropriate knowledge to make sure that the IT infrastructure will be IPv6 ready on time. Regarding this IPv4 service continuity thing, just a couple of words about that. We have decided to deploy network address translation techniques in our networking infrastructures. As you probably know, there are basically two flavors of carrier-grade NATs, one which consists in introducing an additional level of NAT in addition to the NAT which is activated by default in the CPE. This is the so-called double NAT approach. And the other one is to stick to a single level of NAT, where the level of NAT is actually outsourced in the network, and the NAT feature that was activated by default in the CPE is deactivated. We've chosen the latter solution for obvious reasons, because the corresponding DS-Lite technique assumes that the access infrastructure is IPv6 enabled, which means that this is a kind of implicit commitment, if you will, from our side, that we will provision our customers with IPv6 connectivity, and as a matter of fact, we will use the introduction, or take the opportunity of using and operating DS-Lite CGNs to encourage our customers to use IPv6 instead. Which brings me to the next slide. So basically, we need to make sure that our new customers will be able to access the IPv4 internet during the forthcoming transition period. And obviously, today, the current state of the art mandates the introduction of network address translation techniques. We have also defined an exit strategy, which will allow us to rely upon stateless approaches in, say, a couple of years or so, depending on the progress of the standardization effort. so that we can get rid of the NAT boxes that have been deployed into the network to move towards, let's say, a more decent approach to address this IPv4 service continuity issue. So on CGN technology, again, this is, for us, this is not a solution. I'd like to very much insist on the fact that we will only deploy DSI CGNs if we have to. Meaning that there are many, many affiliates within the group which do not need that kind of technique today. This is obviously the case for the African affiliates because the pressure in terms of global IPv4 address depletion in this region of the world is not that high compared to what's going on in Europe. As a matter of fact, in Europe today, only our Polish affiliate will be deploying, and has already deployed actually, because we've been testing the technology for more than a year now, will be deploying DSLive CGNs. And again, the DSLive technique or any kind of CGN technology itself does not address all the issues raised by the introduction of network address translation techniques in the network, especially thinking about our beloved customers who maintain contents in their premises and obviously want to make sure that these contents can be accessed from the internet. If you introduce a DSLive CGN, this does not work anymore. So this is why we also standardized or contributed to the standardization of a specific protocol, namely the port control protocol, which will be used to dynamically control the DSLive CGN so that it can open the appropriate pinodes and make sure that the incoming traffic from the internet will go through the CGN without any too much damage. And yet, obviously, if two customers share the same global IPv4 address and want to use the same port, I can tell you that there is one customer who will be extremely disappointed and frustrated. And we cannot solve that kind of issue. Okay? So this is why I was really insisting on the fact that this CGN stuff is something we have to do in some regions, in some affiliates, but we will definitely take the opportunity of this kind of solutions or techniques to encourage our customers to use IPv6 instead. Moving on the strategy, mobile services. So it's also a dual stack migration technique. So we will first allocate /64 prefixes in addition to the typical either the private IPv4 address, which is usually assigned today by most of the mobile operators. For those customers who use specific dongles to access their own intranet, as you probably know, we assign a global IPv4 address instead, which means that in some of our affiliates, the primary target for introducing IPv6 in the mobile environment will be those customers so that they can be provisioned with the appropriate IPv6 enabled dongles. We have tested a couple of IPv6 dongles for the past 8 months. It works pretty well. And as a matter of fact, one of our affiliates in Europe will be opening IPv6 for these customers, hopefully during the first half of this year. A couple of technical comments. As you probably know, we are also deploying 4G in our mobile infrastructures. As a matter of fact, the completion of the 4G deployments in some affiliates is a condition to trigger the opening of the IPv6 service. And there is a couple of design considerations related to the introduction of IPv6, namely the ability to use a single PDP, a packet data protocol context, to convey not only the IPv4 traffic, but also the IPv6 traffic, for the sake of bandwidth optimization in the access. So today, not all of our mobile infrastructures are actually compliant either with the Release 9 of the 3GPP specs or the Release 8, depending whether it's a 3G or a 4G infrastructure respectively, which means that in that case, our customers will have to establish one PDP context which will be dedicated to the forwarding of IPv4 traffic, and another distinct PDP context which will be dedicated to the forwarding of IPv6 traffic, which is not something which is optimized. So we are also migrating our mobile infrastructures to make sure that only a single PDP context will be used. It also depends on the progress of the technology, because we still have some vendors who are not really IPv6 minded yet, And this is also true for the GGSN or the packet gateway vendors today, which is also something we are working on, hopefully in collaboration with other mobile operators. So this will be the first step. The next step for us in the mobile world will be to assign only an IPv6 prefix. So in that case, this assumes that the applications that may be used by our customers will be able to rely upon an IPv6 stack, hence another issue, because the community of application developers is not necessarily very much aware of the implications of using sockets that may solicit the network layers. And in that case, obviously, we are discussing with this community to making sure that they are developing applications which can be address family independent. This is really critical for us. We are working with that kind of community. It's not that simple, again, because of, let's say, cultural background, but this is something we are trying to develop, again, in collaboration with other mobile operators, and we will probably take the opportunity of the next big events, such as the Barcelona event, which always happens at the end of February, to further communicate on that kind of requirement. And last but not least, I mentioned in this slide, use IPv6 as a machine-to-machine business catalyst. We truly believe that IPv6 can definitely accelerate the deployment of machine-to-machine services. The machine-to-machine environment is a whole world of opportunities. It ranges from the ability to dynamically monitor biometric data to the introduction of wireless sensor networks in the home, which will be composed of motion detectors, smoke detectors, or the ability to remotely control your lighting system. It also includes the introduction of wireless sensor networks in urban environments for different applications, such as the ability to dynamically locate available parking lots, or the ability to meter the pollution or the traffic. And as an operator, we are interested to work with for example, there is a couple of major cities in France with whom we have actually ignited discussions to use IPv6 as the most appropriate federative layer to deploy that kind of service. So there are basically two reasons. Obviously, the number one reason is the almost unlimited addressing capacity, because we're talking about routing environments which are far more different than what we are used to know, especially in the area of urban machine-to-machine services. Today, an IP backbone is composed of something like, say, 300 to 400 routers in the largest networks. We are talking about thousands of network devices, so it's a very different story. And it's not only a matter of making sure that we will be able to rely upon a sufficiently large IPv6 addressing scheme, it's also a matter of making sure that, given the specific traffic patterns of machine-to-machine communication services, mostly a group communication schemes, where you've got all the sensors that report the data they have collected towards a controller, and conversely, the controller will send a set of commands towards a set of sensors. We still have some interesting issues raised by the IPv6 route computation itself. So we are very much interested in what's going on in some of the IETF working groups. We have started some experiments regarding the use of the so-called routing for low power and lossy networks routing protocol, the RIPL, which basically relies upon IPv6. The other thing which is interesting, obviously, in IPv6 is the self-configuration capabilities of the protocol. If you're talking about sensors, very small devices with major CPU constraints, memory constraints, energy constraints, we need to make sure that automation is a key word for the deployment of that kind of services. And from that standpoint, IPv6 is much more attractive than IPv4. Just to give you an idea and show you this is not science fiction, the two diagrams that you have on this slide is something that we have demonstrated 2 years ago during the first IPv6 World Day that was organized on June 8th. So on the left-hand side, this is a wireless sensors network which has been deployed in our Beijing premises. We've got an Orange Labs there, and we are working with them to assess the scalability and the performance of the RIPL networks. They have now deployed this wireless sensor network in some operational fashion, if you will, because They use temperature sensors, which are completely controlled by IPv6. And every colleague within Beijing has the ability to actually decide the temperature of his desk remotely based upon IPv6 from his smartphone. So this is one application, very trivial, very straightforward, and yet this allows us to further assess the design related to the deployment of that kind of service, again based upon IPv6. On the right-hand side, this is something which has been developed by my colleagues from Barcelona, Orange Lab Spain. So this was also demonstrated during the IPv6 World Day of June 8, 2011. There they had deployed a couple of wireless sensor networks, mostly dedicated to the measurement of temperatures as well as humidity. And people on the internet who had an IPv6 connection, especially through a mobile network, had the ability to collect the data that were collected by the sensors, and then play around with IPv6 access and fancy screens. So this is also something which is being further developed. There is actually a Spanish company which has expressed interest in being provided that kind of service. And this is part of the whole Spanish IPv6 migration strategy that was promoted several years ago by Zapatero at that time. So, moving to the very practical part, I will give you a couple of figures regarding the status. This is basically a chart that describes how we work with the different affiliates in terms of project organizations. Basically, we manipulate two major inputs. One input is the estimation of the global IPv4 address depletion on a per country basis, depending on the market coverage, on their business development perspectives, possibly on the traffic matrix, and obviously on some specific business opportunities, especially towards the corporate customers who may have some representation in the corresponding country. And the other input being obviously the IPv6 audit itself, where we help our country affiliates to assess the impact of introducing IPv6 into the different components of each and every service that they plan to deploy or that they already deployed to their customers, so that we can derive the financial impact, for example, in terms of IPv6 introduction. Obviously, training is really key. We've got more than now 1,200 colleagues who have been trained through IPv6 group-wise. And we usually organize an IPv6 workshop with the marketing teams, the engineering teams, as well as the operational teams, so that they can get familiar with the IPv6 technology itself, but also the communication strategy around the promotion of IPv6, which can be very different from one country to another, especially in the African region. And then we proceed with the production of the appropriate documents, the high-level design, which really details the configuration files and how we will proceed with the upgrade of the different components. We usually work with the marketing teams to help them print the appropriate press releases. We organize sometimes what we call open events. This is related to the brand of one of our offerings, which is called Open. And for example, we had organized in 2010 in Dakar a two-day workshop dedicated to IPv6, which was very popular, surprisingly enough, not only because we received the many questions from for the corporate customers of Sonatel, which is the affiliate in Senegal, but also residential customers who were very much interested in being the first to use IPv6 services. So at the end of 2010, we actually deployed, if I remember correctly, 11 CPU routers in Dakar, in 11 customers, and they had the ability to access the internet through an IPv6 connectivity. So communication is really key, and this is why I always insist when we organize an IPv6 project with a given affiliate to make sure that the marketing teams are involved from day one, so that they can prepare the IPv6 communication strategy around the deployment. So this is where we stand. We've got mostly two major zones, one being the Africa and the Middle East, the other one being Europe. Today, the most active countries in the African Middle East zone are those that are listed on this slide. For example, Meditel, which is our Moroccan affiliate, recently presented the IPv6 roadmap to the national agency, telecommunication agency in Morocco. This is because of the Moroccan government who has defined a national IPv6 strategy, and they wanted to make sure that each and every service provider in Morocco had a clearly detailed roadmap. So hopefully our Moroccan colleagues will be deploying the IPv6 pilot deployment during the second half of this year, and the grand opening should be somewhere during the next year, 2014. Mauritius Telecom obviously was somewhat, I would say, mandated to provide IPv6 connectivity, not only because of the presence of Afrinic headquarters in Mauritius, but also because there was a clear demand from the Mauritian government, from a regulation standpoint, if you will, to make sure that each inhabitant in Mauritius will have the ability to access the IPv6 connectivity. So this is something which has been opened last year. Orange Ugandas is also very keen on opening the IPv6 connectivity. They have been registered for the last IPv6 world launch back in June 2012. We can now access their website through an IPv6 connectivity. And basically there are other countries, obviously Senegal, Tunisia, Jordan are very active. There will be openings presumably next year if everything goes well. In Europe, when I mention Romania, I mean Orange Romania, obviously. As you probably know, Romania has ranked #1 and is still #1 today in terms of IPv6 adoption, which was admittedly quite impressive. But Orange Romania provides an IPv6 transit offering for 3 years now. Moldova has completed the 4G deployment in December last year, and they should be opening the IPv6 connectivity service for their corporate customers, hopefully by the end of the first half of this year. And Poland is probably my major focus today, because this is our second largest affiliate after France, and they will be opening in April, which is good. And everything's going well, everything's in sync. We've got weekly meetings with my Polish colleagues. They will be the first to deploy DSL CGN, so we are especially interested in seeing what will be the behavior of our customers regarding the access through DSL CGN. So we see what happens in April. But so far, everything works fine. So this is a basic recap. We have been provided the transit offering in France since 2002. This is something which is mostly used by the French academics, like Renater. Now we've got 20 countries group-wise, which have ignited IPv6 projects. Several pilot deployments started a little more than 2 years ago. And again, Poland will be opening the connectivity service in April, covering both the fixed and mobile environments. And last but not least, the IPv6 VPN service is available through the Orange Business Services entity within the group since May 2009, and it's pretty successful, which is really good news. We have defined with them an IPv6 consulting service back in 2010, so that we can accompany the largest corporate customers in defining their migration strategy, and obviously in making sure that this is something that comes through in a couple of months or so. Last slide, lessons and challenges. So again, it's not very much the introduction of IPv6, which is the most difficult part of the topic. This is something which is quite well known for quite some time. This is typically this IPv4 service continuity, which admittedly raises the most important technical challenges, and again, we do not have any specific solutions. So hopefully IPv6 will become the rule sometime. Some vendors are not IPv6 minding yet. We still have some issues with the STB vendors because we will be providing IPv6, IPTV service offerings. We have some tests with Motorola as well as Samsung, but it's not really convincing so far. So we've got a technical solution to address this issue, but I will not jump into this. Applications should be address family independent. This is already something I mentioned. Making sure that in the developers community, all the applications or fancy widgets that you use on your beloved smartphone can work indifferently over IPv4 and IPv6. And like I said before, both timing, deployments, and communication are key. That's pretty much it. Thank you very much.
Thank you, Chris.